Okay, so here we are, and let's start the lessons for this week. We are in the nutrition lab, and I am in my kitchen. And if you know anything about keeping track of your nutrition, it sometimes can feel like a lab, like an experiment. So let's go in and see what it's like to count calories. And making sure we have enough, maybe not too much. It's a pretty simple equation here. Calories in, calories out. And if one is greater than the other, you gain weight. If one is less than the other, you lose weight. So here we go. All right, imagine this. Imagine it's the middle of finals week. You're cramming information for exams, typing away to finish papers, and occasionally taking deep breaths to maintain your sanity. Now imagine that in this craze, you had nothing to eat all morning and you skipped dinner the night before. When you finally sit down to take your exam, how might you feel? Probably all of those for me. Good old finals week. So, this is to note, this course is made for college students, adapted to 9th grade bio. But for you, it might feel the same way as we're closing in on the end of the semester here. Caloric intake for many people, not having enough food can cause a lot of reactions, including being tired. Whether you're a student on Earth or an astronaut in space, everyone needs to eat to gain energy. The question is, how much? In this lesson, you'll be exploring that question. How many calories does a person need to be healthy? We'll look at what is a calorie, how much energy does a human require, and how can we perform an energy balance on an organism? And perform an energy balance, so we'll be counting up the balance here between what goes in and what goes out. Looks like my internet's a little bit slow here today. Okay, so we're going to look at these two people. Here we have Michael Phelps. He ate 12,000 calories a day while training. Oh my gosh. Teresa only needs 1,600 calories to maintain herself. What do you think affects how many calories a person should eat? Go ahead and select all that you think apply. Age, height, weight, lifestyle, exercise routine, day job, gender. Probably a lot of these could be variables. Fueling ourselves. A lot of what goes into deciding how much a person should eat has to do with the amount of work they need to do. Cells all over the body, including those in your muscles, require a stable supply of energy to function. Athletes who use a lot of energy for exercise require a lot more calories per day. Take a look at the following exercise routine. Predict how many calories Pablo, a student, would burn with this exercise routine. So he has cardio for 10 minutes, 150, cardio 20 minutes, 300. So if we double that, that's probably going to land us around 600. So as you can see, more physically demanding, the more energy or calories it will require. All right, here we have now the work of an astronaut. Although they float around in microgravity, astronauts do a lot more than you may think. Take a moment to look at some of the work your crew will need to do on their mission. Exercise, 2 hours a day, vigorous cardiovascular and weight training, spacewalks, which are physically exhausting and take up to 8 hours. So imagine being in this really clumsy costume, spacesuit, having to go outside of the space station for 8 hours. Setting up a base. Crew members will have to quickly construct a base on Mars to survive, carry out research, and maintain their equipment. The bottom line, astronauts need to fuel their bodies to complete their mission. To do so, they will require energy from food. But the question still remains, how much? Because astronauts are doing a lot of work, does that mean we're going to give them an 8,000 calorie diet? Or would a 1,000 calorie diet be more suitable? It'll be your task to find out. Before you can prevent an energy shortage on board, you'll have to know some basics about how your body obtains and uses energy. Predict how many calories you think an astronaut would need. So go ahead and take a guess. I would base mine over 2,000 because that's the recommended daily value. Here we have your brain taking 19% of your energy, your muscles 18%, other organs 19%, liver 27%. Oh, so energy. We all know that food contains energy that our bodies can eventually use. But how much energy does one particular food item contain? This is going to be an important question for you to answer if you want to make sure your crew gets just the right amount of energy to be healthy. Looking at this food label below, place a star in the area where you can identify how much energy is stored in the food. So there, that's probably, we know calories, and then calories from fat. The calories is the measure of energy. We're all pretty familiar with the idea of calories. We see them everywhere, and it seems like there's an endless marketing for lower calorie options. But what are calories anyway? Based on what you already know about calories, select a snack with the highest calorie content. Chicken, carrots, bananas, almonds, or a donut. Surprisingly, of all the foods you've seen, each of them has a partner that has an equal amount of calories, shown to the right. How is that? Certain foods, like the almonds shown here, are more rich in high energy molecules that break down to produce more energy. Calories are a way in which we keep track of the energy stored in foods. More specifically, it's a measurement of energy potential in food, or how much energy it would take to heat 1 kilogram of water by 1 degrees Celsius. So that's the technical definition here for a calorie. Now, which of the following do you think is a lower calorie option? Just a burger or a burger plus a salad? I think the salad, even though it's not that much, probably has some calories. Strange question, a little bit. Okay, so they're just making the point that, of course, no matter what food you eat, you're going to have calories. There's no 0-calorie food. So far we've seen some foods are more rich in calories than others. The quantity of food is also important in calculating overall calories. Using what you know about calories, select which of the following is a healthier option. So I suppose we're going strictly based on calories, then lower calories in their calculation is better. More than a number. Let's take a look at the selection you made. So here, calories in whole milk versus calories in Coca-Cola. You can see one of the biggest things here is that sugar. 39 grams for the Coca-Cola, 13 grams for the whole milk. So which one is healthier? Maybe you would say milk because it has more nutrients. You can see that nutrients down here, vitamin A, vitamin C, calcium like we were talking about, and iron. The tolls of space travel. Being in microgravity can take its toll on an astronaut. Take a look at how their body weight might be affected by a mission. Which of the following statements match the evidence shown in this table? Astronauts are gaining body mass while in space. Astronauts are losing body mass while in space. Astronauts are dropping down to 70% of their original weight. They're losing 5%, or most of the change in an astronaut's body weight comes from inadequate nutrition. So let's see what we're looking at. Here we have different places, different missions, and the body weight change. It's under 5%, up to 5%. Yeah, that could be pretty accurate. Astronauts are losing up to 5%. And then that would also be accurate. We don't know yet that it's from nutrition. To predict what you think is required to maintain the health of astronauts in space. Here's a positive energy balance. Okay, yeah, that's calories burned through physical activity. Positive energy balance, here's energy balance. Both of them are balanced, or negative. So for things to be balanced, you want them to be balanced. Calories in equals calories burned. How much energy does the body use? Maintaining a balance between how much energy is consumed and how much is expended is not only important for astronauts in space, but also applies to your life on Earth as well. Before you can determine how to balance calories in and calories out, you need to determine what action input calories into your system and what actions are outputs that use calories. So here we go. Eating is an input, exercise, output, digesting food, fueling your organs, output. Oh, digesting food takes energy. That makes sense. Okay, so we put in food. An output that uses the food, another way of saying that, BMR, thermic effect of the food. So let us read more about this. First, we need to figure out how many calories they're burning. The next segment, we're going to get personal. Try to calculate how many calories a person needs. We're going to use you as an example. You'll see how much energy your body uses and use that information to determine how many calories your body needs to maintain itself. Okay, so let's click on the next button to find out how many calories given your basal metabolic rate, or BMR. So here's the BMR. So let's click on this. Eating. Let's just go to the next slide. Turns out your motionless body naturally burns energy just to operate. Sounds surprising, but your body burns calories even when you're lying down or doing nothing. Even though you may be motionless, your body is still using energy to power your internal organs. In short, just being alive uses up energy. This cost of operation is called your basal metabolic rate. Think basal as in base, baseline. In fact, 60 to 70% of the calories your body burns is from this activity. So how many calories does your body burn when you're not moving? The amount differs based on each person. So first we need to say who we are, and then go ahead and enter that for yourself. Okay, and then it should spit you out your BMR. And it is kind of interesting how they get that number. How do they know what your baseline, how do they calculate all? All right, so not surprisingly, feeling the burn burns calories. One of the more obvious ways our bodies use energy or burn calories is through exercise. To get a specific reading on how many calories you burn each day from your daily exercise, you'll have to carefully track each of your exercises, or just most rigorous activities for a less accurate reading. However, we can get an estimate of the number of calories you burn from exercise by looking at your general activity level. Okay, so generally, are you sedentary, lightly active, moderately active, or very active? Gosh, with online school, I think for me right now, I am moderately active, though most of the time pretty active. Here we go. All right. Now next, the thermic effect of food. The thermic effect of food is the amount of energy used by your body to get energy out of food. In fact, it actually takes energy to break down, absorb, transfer, and store the energy from the foods you eat. The thermic effect of food, TEF, accounts for 10 to 15% of the calories you burn each day. This is because your body has to convert energy from one form of food into another, more usable energy source in the body. Someone's TEF can differ based on the foods they've consumed. So macronutrient, remember proteins, carbs, and fats. This is someone's particular makeup. Using the data shown here to determine which macronutrient is most intensive. Oh, okay, hold on. So which one's the most energy intensive to digest? Calories burned, so that would probably be protein, because the number of calories consumed in order to digest the protein is the greatest. Although your diet probably varies each day, you should be able to estimate your TEF, the calories your body burns by digesting food, by tacking on an additional 10% to the calories you've burned from exercise and your BMR. Note this is just an estimate. Try to calculate your TEF using the following two values. Take a look at how we calculate Antonio's TEF. Exercise is 400, BMR is 1800, TEF is 400 plus 1800, so all those together, and then tacking on an extra 10% gives us 220. Okay, so we'll do the same thing for your own numbers. Add those up and then multiply by 0. Okay, and then go ahead and add all of these up for the total amount of calories that you burn each day. So then what calories do you need to balance that? It's going to be the same amount. All right, so here now we have to conduct an energy balance on these astronauts. Not everyone balances their energy usage with the energy they obtain from food. Use the chart below to figure out each person's net energy. Net energy is a term that refers to how much energy you're left with. Is the energy you've gained minus the energy you've used, or inputs minus outputs. Okay. So it seems for this you'd want to add up these three numbers. That's the total amount of calories he needs, and then that's what he eats, and let's see where he's at. So what I got here is that amount, and that is he eats more, so he's in a positive energy balance. More energy is consumed than is being used. Let's do the same thing for Lakia. So we have 400 plus 1500 plus 180. And so she is actually in a net negative energy balance. Right on. All right, so here we go. Oh, that was Coyote jumping across the screen. Here we are. Okay, so eating habits. Making sure you're eating enough calories on a mission is already hard enough. To add this difficulty, astronauts typically experience a change in their dietary habits when in space. Read the testimonials below to find out more. Antonio, there's really isn't a lot of space to move around. It's not like eating at home with a dining table and all. Lakia says, I'm just too busy to eat as much as I should. I've been keeping really busy with all the exercise research and maintenance that I do. And Araceli says, I can't put my finger on it, but I can't seem to taste food as well as I used to. I think it's... Oh, go ahead. So go ahead and rate yourself on each one of these. Again, the calorie being how much it takes to raise 1 gram or 1 milliliter of water 1 degree Celsius. That's an amount of energy. It's also the amount of energy burned when your body uses it for fuel, varying on different amounts for proteins, carbohydrates, and lipids. Here we have energy inputs and outputs. Eating is an input, output being what it's used for, so exercise, that base metabolic rate, or the thermic effect of food. The thermic effect of food being the place, like actually breaking down proteins and fats and carbs takes energy. But mostly it's just general maintenance of your body, and then on top of that, exercise. And then energy balance. As you add all three of those up, how do they balance out with eating? Okay, so I think that appears to be the end of that lesson, and I'm going to go eat some food to fuel my brain before I go on to the next one. And I hope you do the same in between your meals. Eat things with lots of colors in them. Why? What do you think? They oftentimes have a lot of really cool macronutrients, or micronutrients. So we have our macronutrients, and the micronutrients are like all the other little things that your body needs, like choline to support your brain, B12 for energy, iron. And I just wanted to point out this book is super cool, How Food Works. and it's a bunch of infographics on a bunch of different types of food, and I will maybe share some of this on Friday at the live lesson. So, okay.